Okay, so in this video, we're going to be going over this op amp circuit. And the first problem that we're going to do is this right here, where VA equals 1.5 and VB equals 0. So I'm going to copy our circuit right here and paste it so that we can modify it. So VA is going to equal 1.5. 1.5 volts, and VB is going to equal 0. So we can pretty much bring this straight to ground. So right here we have a inverting amp, and we're trying to find V out right here, V out. And the equation for finding V out is as follows. V, do this in pink, V out equals negative R2 or RF. Actually, we'll just name this 2 over R1 times V in. And right here, I will label our resistors. So this right here, this resistor right here is going to be R2, and this is going to be R1. So we'll just plug in our resistor values to get negative 160K over 20K times our V in, which is 1.5 volts. So we will just plug that into our calculator. 160K divided by 20K times 1.5. And we get negative 12. And that is our answer for part A. Okay, so for part B, we're going to have VA equal 3 and VB equals 0. So we will label this as 3 volts and again bring this straight to ground. So again, we will do the exact same process. So V out is going to equal negative 160 over 160K over 20K times 3. So doing the exact same process, we get that V out is going to be equal to 24. But let's look at our op amp and see that it is receiving 18 volts through the negative and the positive. 18 volts through the negative and or positive 18 volts and negative 18 volts. So this 24 is actually going to be saturated because it is greater than 18. So that means that our V out is actually going to be equal to 18 volts. Okay, next, for part C, we are going to have VA equal 1 and VB equal 2. So we'll label this as 2 in yellow, 2 volts, and this as 1 volt. Now, this is going to be a differential op amp. So it's going to have a different equation. So the equation for a differential op amp, the equation for this is going to be V out equals 1 plus R2 over R1 times R4 over R3 plus R4 times V2 minus R2 divided by R1 times V1. So this is quite long, so first I'm going to label the resistors that we will be using. So this is going to be R2, this will be R1, and this right here will be R3. So on screen, I have brought a completely simplified differential op-amp circuit. So as you'll see, we actually do not have an R4, which means that most of this will become 0, and we are just left with this side. So we will plug in our resistors. So R2 is 160 divided by 20k times 1. So plugging that into our calculator, we get a value. Okay, for part C, we're going to have VA equal to 1 and VB equal to 2. Now, this amp doesn't follow any of our most simplified amps, so it is closest to our differential amp, which is going to be this right here minus this side. So we need the voltage going through our 5K, which is going to be the equation for a non-inverting amp. And the equation for our non-inverting amp is V out equals 1 plus R2 over R1 times our V in. So if we get our calculator out, 1 plus, and again, this is our R2, and this is our R1. And this right here is going to be our VB. So plugging in, we get 1 plus 160k over 20k times 2. And in doing so, we get 18 volts. Now, for this side, right here, this is a non-inverting amp, or this is our inverting side. So we'll use the equation for a non-inverting, or for an inverting amp, which is going to be negative R2 over R1 times VA. So when we plug all of that in, it is the exact same, or not the exact same. When we plug in our variables times 1, we get 8. And now we will do our 18 right over here, our 18 minus 8 to get our V out of 10 volts. Now, to write this a little better, what we are doing is we are taking the voltage from this node and subtracting it from this node. So we can rewrite our equation as such. V out is going to equal 1 plus R2 over R1 times VB minus R2 over R1 VA. So now that we have that, let's solve the question. VA equals 4 and VB equals 6. So let's label our voltages as such, 6 volts and 4 volts. Now let's take the equation we found before and plug in our numbers. So V out is going to equal 1 plus 160K divided by 20K times 6 minus 160K over 20K times 4. Now, let's plug everything into our calculator and we get 22. V out is going to equal 22. But remember, looking at our circuit, this voltage is going to saturate because the maximum voltage is 18, or the maximum voltage that we can get is 18. So our V out is actually going to be 18 volts. Okay, so let's move on to part E. So for this one, we're going to solve if VB equals 5.3, specify the minimum value of VA such that the amplifier does not saturate. So, in order to do this, we're going to want to use the equation that we have been using previously. But this time, we are going to set V out to negative 18, since negative 18 is the minimum value, minimum voltage that we can get. So, I'll rewrite our equation. So 1 plus R2 over R1 times VB minus R2 over R1 VA. So I'm going to plug in all of our knowns here. Actually, plug in all of our known values. So this V out is going to be negative 18, since that is the minimum value that we can get. Equals R1 plus 160K divided by 20K. And for VB, we have that as 5.3 minus 160K divided by 20K times VA. So we will just solve this using algebra. Very simple algebra. So when solving this, we get 57.7. And when solving the other side, we get divided by 20. Okay, we get 8. VA equals 118. So now we can subtract this 47.7 to the other side. So negative 18 minus 47.7 gives us negative 65.7 equals negative 8 VA. And now we just divide this by 8. And the minimum value that we can get, that A can be, to get the minimum value VA is 8.22 or 21 when rounding. So I made a mistake. This is not the minimum value. This is the maximum value. Now, to figure out if this is the max value, we just use the other saturation point, which is 18. So we will take this right here, since this is our simplified, and plug in 18 instead of negative 18. 47.7 minus 8 VA. So we'll do the same thing as we did before. 18 minus 47.7 divided by negative 8. And this gives us a VA of 3.713 volts. Now we just compare these two, and we find that this is the smaller one, so this is our minimum, and for VA, this will be our maximum.